Welcome to the second part of this Unity Basics tutorial series. My name is Christina and I will be your guide through this tutorial series. In this tutorial series, we will continue from where the first part ended. We will add several new features which will make the game more interesting to play. In this episode, we will improve the jumping mechanics. Let's start by opening our Unity Basics project if it's not opened yet. If you have updated Unity and you open a project which was done with an older version, you might see this arrow here. To fix this, go to Project Settings and select Player Category. Change the script and runtime version to net 4x equivalent. Then click Restart. Next, we need to import the Unity package that includes the assets we need for this course. Head to Nitomani School's webpage and download the Unity Basics 2 package from the Resources section. Then import the package to the project. Make sure that all the components are selected and hit Import. Let's create a new scene and name it to level 3. Remember to add it in the build order. When you are done, open the scene. Drag the UI and player prefabs to the scene. Then, add few pieces of ground under the player. Next, create an empty game object and give it a name of your choice. Reset the position and drag the ground pieces inside of it in the hierarchy. Then, add a box collider 2D component to the empty game object and adjust the collider's boundaries. Next, let's slice the ground 2 sprite in the Sprites folder. Select it and change the sprite mode to multiple. Then click Apply and open the sprite editor. This sprite sheet introduces some new ground pieces that we can use when designing levels. Click on Slice, choose Grid by Cell Size, change the pixel size values to 256 and hit Slice. Now the image is sliced properly. Click Apply and close the sprite editor. Next, drag few of the diagonal ground pieces to the scene and make a small slope that the player can climb. When you are done, create an empty game object and drag the new ground pieces inside of it. Then give it a polygon collider 2D. Let's adjust the collider. Click on the Edit Collider button and drag the collider from the dots so that it covers the slope we made. After that, remove the extra main camera from the scene and activate the play mode. I will demonstrate the problems of our current jumping mechanism. We are able to climb the slope, but if we stop, the player starts to slide down. Jumping on the slope doesn't work either. The second issue is that if we move towards vertical walls while in midair, we can prevent the player from falling and we can even jump. Let's take a look at the player script. In order to jump or stop, the speed on y-axis needs to be 0. Gravity is pulling us down the slope, and therefore the speed is not 0. That's the reason why we can't jump while standing on a slope. Likewise, we are able to prevent the player from falling down and jump at the same time by hugging the wall. Alright, let's start fixing these issues. To solve this, we will write code that creates a line between 2 points and detects the colliders that hit it. First, let's go to Unity to modify the player game object. With the latest version of Unity, modifying of the prefabs has changed a bit. If you have the older version, you can do the modifying in the old way. Right-click on Player and choose Open Prefab Asset. We can see that the hierarchy only displays the structure of the prefab after we open it. Now we can properly modify the player. Remove the Box Collider component and replace it with Capsule Collider 2D. Change the size on X to 0.56, then on Y to 2, and then offset on Y to -0.22. The reason why we changed the box collider to a capsule is that the round shape is more suitable for climbing slopes. Next, create an empty game object as a child of the player. Name it as Crown Check. Change the Y position to -1.4. We will use this empty object's position to define the length of the line. Now we can exit the player prefab. You can do it by pressing the left pointing arrow icon on top left corner of the hierarchy, or by clicking the Scenes button from Scene View. Before switching the code, we will assign a layer to all the objects that we want the player to be able to jump from. By this way, the line will ignore all the other game objects. Select one of the empty game objects, which has the crown pieces inside of it, and choose Add Layer from Layer menu. Write Crown on User Layer 8. Then select the game object again and assign the newly created layer to it. When Unity asks about the child objects, choose No, this object only. Do the same to the other crown objects on the other levels as well as to the crown's prefab. When you are done, open the player script. During this course, we will write a lot of code, so now is a good time to start commenting. By that way, it's easier to locate different sections of the code. I will arrange these variables at the top first. Okay, let's start refining our jumping mechanism. Now we will create two new variables that will store the crown check game object at the crown layer. Write public transform crown check and under it public layer mask ground mask. Then in start function, write ground mask equals to layer mask dot get mask parenthesis and ground in double quotes. This line will search for a layer named ground. Make sure that the name you write here is same as the name you gave to the layer earlier. Next, let's write a new Boolean variable. Write public bool hit ground. Now we can write the code that creates the line. We will do this in update function. So, above fixed update, write void update, parenthesis, and curly brackets. Inside of update, write hit ground equals to physics2d dot linecast and parenthesis. Next, we need to define starting and ending point of the line and a possible layer mask. We want the line to start from the player's position, end at the crown check's position, and only detect the colliders that are on ground layer. So, write transform dot position, comma, ground check dot position, comma, ground mask. This boolean will be true when the line hits the colliders that are on ground layer. So that's how we know when the player is on the ground. For testing purposes, write debug.drawLine parenthesis transform dot position, comma, ground check dot position, comma, color dot red. This will draw a visible line in the scene view so that we can see where the line hits. It won't be visible in the game itself. Okay, let's test this in action. Save the script and return to Unity. Before starting play mode, select player and drag the ground check game object into variable slot. Then click on Overrides in the inspector and hit Apply All. If you have an older version of Unity, you can just click Apply directly instead of Overrides. Now, when we start play mode and pause it, we can see the red line in the scene view. And when we keep the player selected and jump around, the hit ground boolean gets switched on and off correctly. The reason why we define the line to be of this size is that it needs to be long enough to reach outside of the player's collider and hit the ground even on up and downhill, but short enough to do so just before the player lands on the ground. Should it be longer, the hit ground boolean would be triggered too early, and we could jump again before the player lands. Let's get back to code. Replace a math dot approximately with hit ground on both the if statements that have it. Next, take a look at the if statement which checks if we are falling. Currently, there is only one condition which is met when the speed on y-axis is less than 0. This doesn't work properly in the case of standing on a slope, so we need to add a second condition to the statement. After the first one, write 2 ampersands, then exclamation mark, and hit ground. Now the animation will be switched to falling only when the speed on y is less than 0 and we are not on the ground. Let's test this. Save the script and return to Unity. This is better already. We can jump while on the slope, and the player doesn't slide down like it used to. Also, we can't jump from the wall anymore. Good job! Now we have solved one part of the problem, but there are still few issues. The falling of the player slows down a lot when he is close to the ground. This is because the line hits the ground before the player. Also, the player can still hang from the wall. That's possible because the player has a certain amount of friction. We will fix these issues in the next episode. Remember to save the scene. See you in the next episode.